Guys, as you can see, we have a bulb here which is being toggled. This is a 220 volt AC LED being toggled by our PIC16F877A microcontroller with a delay of 1 second, because we have this circuit over here. Here, instead of having this for the simulation, I'm using the microcontroller pin number B4. Then we have a resistor, then we have an NPN transistor. This NPN transistor is used to trigger the relay. This is a flywheel diode. Its job is to maintain the direction of the coil current, and there we have the power for the coil. Like for this relay, it's a 24 volt relay in our case. And then at the normally open end, we have connected the bulb, and bulb is then connected to the wall socket. In this way, this is the circuit we are using here. And for the programming, I've just used a simple pin number B4. I initialized the pin, then I turned it on for 1 second and then turned it off for 1 second, and then it's a forever loop. So this is giving us this result over here. Hello guys, welcome to learning microcontrollers. In this video, I will show you how we can interface a 5-pin relay with a PIC16F877A microcontroller. I will show you how this relay works using a multi-sim live simulation as well. So first, let's get to which relays I'm talking about over here. 5-pin relay. Okay, on the internet, if you see, there are various type of relays in the market. Remember that a 5-pin relay is the one which have both are normally open, like this one, very common, this cube type relay. You also get it on a module as well. It have two coil pins, one normally open, one normally closed, and a COM pin. Now this is a very common relay. This such type of relays I'm talking about. Such relays, it may be in various shapes and sizes. This is also 5-pin relay, have A, B coil pins, one normally open, one normally closed, and a COM pin. Okay, now this is great that we know we have relays. Now what I do is that let's get to the microsim. Okay, I write here microsim live. I have a video on this, a tutorial how you can use it. It's a free software up to 5 components and very cheap, like $1 a month for premium versions. I think it's $2 to $3, so it's very cheap, negligible cost as compared to its functionality. Just go there, click on the create circuit. If not logged in, log in. Okay, let me open the magnifier as well. Now see, on the left side you have the toolbar. On the left side, look for the component called this modeling blocks, electromechanical. Relay is basically an electromechanical device. So you have a normally open relay, normally closed relay, then you have a combinational relay. Combination is a 5-pin relay. Now see over here how many terminals it have. These are the coil A, coil B, or you may call this A, B, whatever you want. Then you have separation, and then you have a common. This is the common. This is normally closed and this is normally open. In other terms, you may draw it as it have multiple symbols. Now the second symbol that is also available, go to the symbols, this one. It is also clear, sometimes it is shown like this because this is the common port, common, normally open and normally closed. This is the common. So we use the other symbol. Both symbols are fine. You may keep whichever you want. So I double click on it and I select the other symbol. Seems very easy to understand to me. Okay, now this is the relay. Now triggering voltage of the relay depends. Usually it can be from 5 to 12 volt, like 5-pin relay, whichever you buy. On the relay it is mentioned 12 volt, on some it is 5 volt, some it is 24 volt. It depends upon you, whichever you buy. So whatever the relay is, you know the voltage. Now let's make the circuit. So I will not be using a microcontroller here in the simulation, but we will be writing a firmware on the hardware. So let me introduce you to the hardware as well. So this is the hardware. This is the PIC16F877A, and this is the relay I have connected, and this relay is connected to the bulb. And now how it is connected, that you will see on the simulation software. So simple circuit, just a relay connected to the PIC using a transistor and a diode. So let's make this circuit first. Okay, this is the relay. Now go to the left. On the left side, go to the diode terminal. There you have the diode. Bring the diode, rotate it, rotate it like this. Place it here. Now its anodes, cathode side will go to the side from where your power supply is connected, Anode side will go to the side at which the transistor is to be connected. Now bring in a transistor. You may use any NPN transistor because the triggering current of the relay is like 20 to 30 milliampere. BC547 is enough. So that is just a symbol of the transistor I'm using. So connect it here like this. And now for the base pin you need a resistor. Just connect a resistor over here. Now at the back, instead of the microcontroller, we will be using a switch, SPST switch, to turn on and off the relay like this. And behind it we need a voltage source representing the voltage coming from the microcontroller to trigger the relay. So I call it this one DC voltage, this one like this. And you can also double click on it and change the symbol to this. Very easy to understand. So it's 5 volt. Okay, that's fine. PIC gives 5 volt. So I connect it here, the 5 volt. Then from the button in series, we go to the resistor. 1 to 10K is enough for triggering a BC547 type transistor and to the base pin. Now the ground of this will go to the emitter pin of your transistor like this. And this circuit, you will also connect to the common ground, because this will also be the common ground of our whole circuit like this, because this is the requirement for the simulation. Okay, this ground. Okay, now it's connected. Now on the above side, this side, we need another power source which will be used to trigger the relay. That's why we use a transistor, because relay requires more current. We cannot give that much current through our microcontroller's pin, and it may damage the pin. So we use a transistor. Transistor will allow us to give it more voltage, more current, because it is working like an amplifier or a switch. So we use another voltage source. This will be another source for triggering the relay. Again, we change the symbol. I make it like, so suppose our relay is 24 volt. So this voltage will be 24 volt. Depends upon what type of relay you have. If it's 5 volt, you may give it directly from here as well. No issue. So connect the positive here, and the negative will go to the common ground of your circuit. Okay, click over here, take it to the common ground. So this is the common ground of the circuit. That's why I use a ground symbol to make sure that we know where the common ground is, like this. Now on the other side, now this is isolated. There we will connect any load we want. So we use a bulb here. So a bulb, this lamp, I took it from here. On the left side there is, okay, let me show you. On the left side there is indicators. In that you have this lamp. Just pick it up, place it wherever you prefer. I place it right here. Now this is the bulb. Okay, in my case I have a 220 volt AC bulb connected to the AC supply. So you may use whatever available or whatever you have here. So we like write it 220 volt. I think it's DC, but still doesn't matter. And the power, I make it like, okay, 220 watt. Okay, no, we made it like 15 watt. And the burnout voltage we make 240 above it. So this will be the voltage. Although it is DC, but I'm just simulating, so I'm just using it for simulation purpose. Now one end of the bulb goes to the ground, other to the power. So another power source, which in my case is the voltage from the wall socket, go to the left, take another DC source, because it's a DC bulb. Here on the simulation, I don't know, do we have the AC bulb or not? Do we have one? I don't think so. We have the AC bulb, or there might be the setting for this, but I cannot see it. Okay, just no issue with that. We just are doing the simulation, so we can play with this. We change the symbol, make it 220 like this. Okay, connect the positive end. Now see, the positive end will not go to the bulb. Usually it goes to the bulb. So we connect the negative end to the supply like this. Now the positive end will not go directly there. The positive end will go to your relay's common pin. Now it's up to us what we want. If we connect it to the normally open, once the relay gets triggered, only then it will turn on. If I connect the bulb here, okay, first I connect the bulb here like this. Now it's connected here, and again you have to do one thing. You have to ground it for the simulations purpose. Give it a ground here, so the simulator understands that there is a ground. Okay, Now we have left the normally closed empty, because right now our bulb will only turn on if the relay is triggered, because we have connected it to the normally open. Once the relay is triggered, this becomes closed, this becomes open. Okay, I run the simulation. See, simulation is running. Okay, bulb is off. I click on the close, bulb is on. Okay, by default the bulb is off. That's fine. Now what I do is that I do some changes. I delete this, I connect it to the normally closed wire now, like this. I run the simulation. Now see, the bulb is on by default. Only bulb turns off when I turn this off. Now it's inverted, see, like this. Now again I do the same. The pattern way is to go here, like this. Now this is perfect. Now again I turn on the circuit. See, the switch is open, the bulb is off. Switch is closed, the bulb is on. So in our microcontroller, now we will program it in such a way, when a 1 is sent, this bulb will turn on. If a 0 is sent, bulb is turned off, because we have an NPN transistor and the bulb is connected to the normally open of the relay. So this is how this relay works. You have to power up the coil, and then you have to give common. Common can be the positive of, like, it's a series. In series you keep your circuit. Like positive, instead of going directly there, comes through the relay, either from normally closed or normally open. So we connected it with the normally open pin. So normally closed go floating, and once the relay is triggered, this become closed, so the bulb turns on. So that is how it works. Now let me give you a demonstration using the microcontroller. So we go to our MIkroC for PIC. This is MIkroC for PIC. I go to the file, new project. Click on next. Write the name of the project. I write relay 5-pin relay 5-pin tutorial by learning microcontroller. Okay, select the path where you want to create the hex file. Select the microcontroller. I have PIC16F877A. The crystal at pin number 13 or 14 is 20 MHz. Click on next and finish. Here you go. I press control. Before you do anything else, save your work. Click here, save it. Now guys, the pin I have selected on my hardware for the relay is pin number B4, this one, B4. Like B4 pin is connected here. You can call this to be the B4 pin here. This is my B4 coming from the B4 pin. Rest is same. Instead of connecting it here, I have connected to the microcontroller B4 pin. So I program the B4 pin right here. Trace b.f4 equals to 0. So this command trace is the name of the register which defines the direction of a pin. B is the port. This is the pin name. 0 means the pin has been declared as output. So for the relay we need an output pin, because we are sending data to the pin. So by default I want the relay to be at 0, because as per the presentation, simulation, why I set it initial state to 0, because we have an NPN transistor here. If we have a PNP transistor here, then it is inverted. If you give a 0, it's on, 1 it's off. But in our case we are using NPN here. With an NPN, 1 means on, 0 means off. Then also the bulb is connected to the normally open side. So normally open side means when the relay is triggered, like you give 1, then the bulb will turn on. If it was connected at the normally closed side, then it was to be opposite. So by keeping these conditions in mind, our default state, that is when nothing is happening, should be 0. So at 0 the relay is off. Relay is off. So we give some initialization delay, not necessary, but I always suggest you give it in the one-time loop. Now we move to the forever loop. Write down while 1. Forever loop starts here, ends here. So we just write a simple code that the microcontroller will turn on the relay for 1 second and then turn it off for 1 second. So our bulb will trigger by 1 second. So, toggle by 1 second. So this is the initial state. Copy it, paste it here. We make it 1. Now it's no longer 0. Then the delay, copy it here. We make it 1000, like 1 second. And then copy this again. Now turn it off. So we will be toggling the 220 volt AC bulb with this relay. I click on build. Okay, it's built, successfully built. Okay, I go to the PIC16 programmer tool. I have a video lecture on this. Please check it out, how to download and install and use this tool. Click on file, import. Actually, this is the file. Click on write. Okay, the new file is being written. Let's go to the hardware and see what happens. Okay, let us write the new file. Then we will power up the circuit using the PIC16. From here, wait. Okay, the circuit is powered up. Now see, the bulb is triggering with a 1 second delay. Now this relay is doing it. We have just powered up the PIC with 5-volt supply. Why the circuit is triggering? Because we are using this relay. Relay can support a current of up to 10 ampere, this small 5-volt relay. So this is the beauty of using these relays. Like, you can trigger a load of up to 220 volt AC and up to 10 ampere, 20 ampere, whatever the voltage, doesn't matter. Your circuit over here is very simple. So again, this is the story here. Here you have your microcontrollers, 5 volt or 3.3 volt. It triggers a transistor. Transistors triggers the relays, and relay triggers your load. Simple. So guys, this is it. I hope you guys learned something from this video. So we'll see you in the next video. Goodbye until then.